This video will quickly and briefly introduce you to graphing quadratics. So we're going to go ahead and look at the equation, and we're going to set it equal to y, and it will still be the same standard form quadratic that we've been working with in our factoring unit. When graphed, this makes a curve. It's called a parabola. And the shape, it either opens up or it turns down. So here we'll do one that opens up, and here we'll have one that turns down. And the way that's determined is by the lead coefficient. So if A is positive, if A is negative. And remember, the lead coefficient's the coefficient on the quadratic term or the squared term. So that determines the direction of opening. And let me move the screen up just a little bit. And let's complete. If A is positive, then the parabola opens up. And sometimes that's referred to as concave up. Concave up. If A is negative, then the shape is concave down. Concave down. And so now to look at the examples. Here, A is positive 1. Here, A is negative 1. So this shape would turn up. This shape would turn down. Concave up, concave down. And that's determined strictly by the sign of the lead coefficient. So we're going to plot a few key points on the curve. The axis of symmetry is a vertical line that bisects the curve. And bisects means cuts it in half. Bisects the curve. And the axis of symmetry, sometimes you'll see it referred to with the initials AOS. There's a formula for that. X equals negative b over 2a. And the a and the b come from the standard form of the quadratic. Remember, the vertical line, the equation of a vertical line, is the equation x equals, and when you graph a vertical line, just to go back for a second to review that, it's a line that will go through the x-axis, vertically through the x-axis. And we derive the axis of symmetry from the formula x equals negative b over 2a. Just a little review there. One of the key points on the parabola is the vertex. And the vertex is an ordered pair. So it's an ordered pair with an x-coordinate and a y-coordinate. We have a formula for that. The x-coordinate of the vertex is also derived by the formula negative b over 2a. The y-coordinate, and I'll go ahead and use function notation, but I'll show you how it works. The y-coordinate is derived by taking that value, negative b over 2a, and you evaluate the quadratic that you started with for that value. And then the outcome of that gives you the y-partner, the y-coordinate. So the vertex is derived by using these formulas. The axis of symmetry is just simply a vertical line. When the vertex is the lowest point, meaning your shape turned up, it's called a minimum value, or a minimum. And if your vertex is the highest point, meaning that your graph was concave down, it's called a maximum. And it's also worth noting that the vertex is the only point without a symmetric partner. And we'll explore this in class, but along a parabola, points occur in symmetric pairs, equidistant from the axis of symmetry. The only point without a symmetric partner is the vertex, which is either at the very top or the very bottom, making it a minimum or a maximum. And we will look at some of this over the next few days. Okay, let's go ahead and do a few examples so that you understand what you're asked to do just to get started. In example number 1, we're just asked to find the axis of symmetry in the vertex. So let's identify A, B, and C. A is 1, B is 8, and C is positive 15. So the axis of symmetry is derived by the formula x equals negative b over 2a. So here, x would be the negative signs built into the formula, and I'll use I will use the numbers I'm substituting in. I'll put those in red. So what's written in blue is part of the formula. So I've got a value of 8 for B and a value of 1 for A. So that means that the x-coordinate is negative 4. So that means that the axis of symmetry is the vertical line x equals negative 4. Now the vertex is the ordered pair with an x and a y, so I already know that the x-coordinate for the ordered pair is 4. All I have to do now is figure out what the y-coordinate is that goes with it. So to use a little bit of function notation, this notation is just simply telling me to take the original quadratic, and everywhere that I see x, I will let that x become a 4. So here, y is going to equal negative 4 squared, that's f of negative 4, negative 4 squared plus 8 times negative 4 plus 15. So by doing this, this gives me the or the y coordinate rather. So I have positive 16 minus 32 plus 15, and that gives me negative 1. Let's see, that's going to give me negative 32 plus 31, giving me negative 1. So my axis of symmetry is negative 4, my vertex is negative 4, negative 1. Let me erase some of the ink, and we'll do a rough little sketch for this graph. So here's my axis, x and y axis, and this is all you need to do to go along with this problem set. I have my x-axis, my y-axis. When I look at my lead coefficient, I can see that A is positive, so that means that this graph is concave up. I plot the vertex, negative 4, negative 1, so it's going to be down here in quadrant number 3. And here's my axis of symmetry, going to divide it in half, and then I come along with my curve, trying to at least center it around there, and that's all you need to do for this particular set of exercises. Just get familiar with the formulas, direction of opening, and funnel the shape in where the vertex is. Draw an XY grid, place the vertex in the proper quadrant, and then direct the opening of the graph depending upon the lead coefficient, either up or down. And I think that's all we'll do. I think let's do one more on the video, but I think for this particular exercise set, just becoming familiar with these skills is enough. So let's look at number 2. Let's identify A, B, and C. A is negative 1, B is 10, C is negative 23. So this graph will turn down, since the lead coefficient is negative 1, this graph will open down, concave down. The axis of symmetry is going to be 10 over 2 times negative 1. So that gives me 10 over 2, since I have 2 negative signs. So that means this value is 5. So this is going to be the vertical line, x equals 5. And now for my vertex, which is the ordered pair x, y, the x-coordinate of the vertex is 5. To find the y-coordinate, I'm going to go ahead and use the function notation. So this is simply telling me to go back to my original quadratic. Everywhere I see an x, I let it take on the value of 5. So I'm now going to have the negative sign in front. I square the 5 for 25, plus 50 minus 23, and that leaves me with 2. So the y-coordinate of the vertex is 2. So I've now calculated the vertical line that bisects the shape. I know where the vertex is. So let's do just a rough sketch. And I think that's going to be enough to get you through this particular exercise set. So draw yourself an XY axis. And now plot the vertex in the proper coordinate. So this is going to be 5, 2, so that puts me in this, the first quadrant. This shape turns down, so I'm just going to turn down. Here's my axis of symmetry. And just to put a little visual with this, just a glimpse of where we're headed, points on the parabola occur in pairs, and these pairs are equidistant from the axis of symmetry. If I have a pair of points crossing the x-axis, those are my roots. My x-intercepts or roots would be where I cross the x-axis. And then if the graph crosses the y-axis, that would be a y-intercept. So you can see that the points are occurring, well, we'll analyze this more, but the points do occur in pairs equal distance from that center line. The only point without the symmetric partner is the vertex. So the big takeaway from this video is to be able to calculate the axis of symmetry and know that it's just simply a vertical line, and to be able to calculate the vertex knowing that that is an ordered pair, and then roughly sketch in by plotting the vertex in the correct quadrant, and then I'm sketching the graph depending upon concave up or concave down, and then we'll add on skills as we go.